Welcome to this tutorial about transponders and muxponders for WDM networks. A telecom operator with many different customers as subscribers may not want to connect directly into the routers and switches in the enterprise networks of the subscribers. Hence, there is a need for some sort of demarcation device between the operator's network and the enterprise networks. Such demarcation between networks can be performed by a transponder. In a real installation, the transponder is normally part of the operator's network, managed by the operator, and can be seen as his last outpost towards the subscribing enterprise. The transponder is a device that can take electrical or optical signals in a specified format and convert them into optical signals for transmission over a WDM line system. The incoming signal from the client can be either electrical or optical. For example, a gray non-DWDM signal that must be converted to a DWDM wavelength. The transponder may also encapsulate the incoming client signal in a digital wrapper used for error correction and encryption. At the other end of the link, the wrapper is removed, and the data is forwarded to the receiving client in the appropriate format. The signal processing performed by the transponder has both advantages and disadvantages. One disadvantage is that the transponder normally is adapted to the traffic type generated by its client, and therefore not as transparent as an open WDM line system. A transponder can, for example, be used to adapt short-range, non-DWDM signals to a modern and higher bitrate DWDM line system. In this example, the upper router can already be equipped with pluggable DWDM transceivers, while the lower router only supports gray transceivers with a limited reach. The transponder is then used to convert the gray signal into the proper DWDM wavelength. This is an efficient way to migrate existing equipment to a new, high-capacity open line system. A further development of the transponder is the muxponder, which takes several incoming client signals and multiplexes them into one outgoing, high-speed DWDM channel. This is a valuable feature when your line system can transport data at a high bitrate, such as 400G, but your routers only support 100G. Using the muxponder, 4 100G clients can then share one 400G DWDM channel on the fiber and take advantage of the lower cost per transported bit available with a 400G line system. The muxponder performs time division multiplexing of the incoming signals. The incoming bits from each client are queued and then sent in series, one after each other, over the line system. Thanks to the higher data rate of the line system, no bits are lost, and the signals can be reassembled at the receiving end again. Migrating from 100G to 400G using, for example, the Smartoptics 4x100G Ethernet muxponder is easy. First, when a 400G capable line system is in place, muxponders can be used to adapt existing 100G routers to the higher speed communications channel. When 400G routers then are installed, these can be directly connected to the DWDM line system using 400G transceivers with multi-lane capability. This enables the 400G router to interwork with the 100G routers in other parts of the network. In the final step, the routers are interfaced directly to the 400G open line system by pluggable 400G transceivers. The muxponders can be removed and reused at other sites with 100G capable routers. Routers with 400G gray, that is non-DWDM transceivers, can also be added to a 400G line system by use of a 400G capable transponder. Hence, as shown in this picture, the use of transponders and muxponders enables a convenient mix of clients with different data rates and using different types of optical transceivers, all for the benefit of the economy of the customer. This ends this tutorial. To learn more about optical communications, just continue with the next tutorial in this series.